Hey guys, today we're going to talk about balancing equations. So before break, we got to watch the reaction of sodium and water, right? Reaction of sodium and water. And so when you write a balanced equation, or you have to write your chemical equation first, and how you do that is on one side you write the reactants, and then you draw an arrow, and then you write the products. So in our reaction, the reactants, or what we started with, was sodium and water. What we ended up with was sodium hydroxide, NaOH, and H2. That would be a hydrogen gas. And the hydrogen gas is what got ignited and exploded when we watched that reaction. So this would be how you write a balanced equation. You kind of add up. So sodium plus water, and then an arrow, not an equal sign, an arrow, and then sodium hydroxide plus H2. So one thing we have to look at and consider is the law of conservation of mass. And so of matter. What this law says is that matter can't be created or destroyed. And how this applies to chemistry, that means you need the same number of atoms on each side. So we need the same number of sodium atoms on the left side as we do on the right side, the same number of hydrogen atoms on the left side as we have on the right side, the same number of oxygen atoms on the left side and the right side. Now let's see if we've got that right now. One little side note, these little small numbers are called subscripts, and they tell you how many of each atom you have. So let's look at our reactants. On the reactant side, we have sodium, hydrogen, and oxygen. We have one sodium, two hydrogens, and one oxygen. On the product side, we have sodium, hydrogen, and oxygen as well. We have one sodium, three hydrogens, and one oxygen. Now this violates the law of conservation of matter because there's two hydrogens on one side and three hydrogens on the other side. Well, where did that extra hydrogen come from in the product side? That's impossible. So that's why we need to balance the equation. So here's what we have right now. We have too many hydrogens on the product side, or the red side. So we need hydrogens on the reactant side. So in order to add a hydrogen, we have to add a whole H2O. So let's add an H2O. All right, well now we have a problem because now we have too many hydrogens on that side, on the reactant side now, and too many oxygens. So on this side, we need hydrogens and oxygen. So what we can do to add that is add another NaOH. All right, well that throws us off balance again now, because now we have two sodiums, or two NAs, on the product side, and only one on the reactant side. And so this is saying that we need an Na then on the reactant side. So in order to get this equation balanced, we'll add an Na, and now we're perfect. We've got two sodiums, four hydrogens, and two oxygens on both sides. And this is a balanced equation. So we count up each molecule or atom that we have. So 1, 2 sodiums, we write a 2 in front. Right here, write a 2. All right, so let's count the waters. We have 2 waters, so we write a 2 there. We have 2 sodium hydroxide on the product side, so we write a 2 there. And we only have one H2, so we just write a 1, but you don't actually have to write a 1 because chemists don't like 1s for some reason. So these numbers in front are called coefficients. And so the coefficient tells you how many of each molecule you have. So the subscripts tell you how many of each atom you have in the molecule, and then the coefficient tell you how many of each molecule you have in the reaction. And then this gives you a ratio. So the ratio is 2 sodiums per 2 waters. Gives you 2 sodium hydroxide per 1 hydrogen gas. And that's balancing equations.